Okay. Can you hear me? Yeah, I think
Check.
so, right? Yeah. Okay. I think we're right on time to start. So welcome everybody to our talk today about Apache Pulsar and Apache Kafka. We've decided to do this talk, Ko and I. We met actually last year at Devoxx, Belgium.
Yeah, indeed.
Yeah, that's right. And then I was talking about Pulsar. I think Ko was talking about Kafka. So both of us, we got a lot of questions. I got asked about Kafka. How does it compare with Kafka, Pulsar? And then Ko got asked about how does it compare with Pulsar. So we decided let's do a talk together. So here we are. So welcome to our talk, Best of Both Worlds, Apache Pulsar and Apache Kafka. Okay, cool. So Ko, let's first ask the golden question. What is better, right?
I think Kafka is better. What do you think?
I think Pulsar. I think Pulsar.
What do you think? Who think Kafka is the better choice?
So many of you, wow.
And a Pulsar? Maybe Pulsar is better?
Yeah.
It's half on half or something. So.
I know.
So maybe we can ask someone else.
That's true. Let's ask. How about ask ChatGPT?
Yeah, let's do it. It's
Yes.
already a theme on conference nowadays, right? So
That's right.
yeah, let's do that. Let's mirror this first.
Sure.
Oh, wait. So, which one do you want? The one of Google, I have Claude, ChatGPT, or ChatGPT 4? Which one are we going to do now, do you think?
Let's try the one that we think is most accurate. What do you think?
ChatGPT 4. I hope I still have some messages left, so let's try.
That's right.
Which is better? Apache Pulsar? Pulsar or Apache Kafka? In one sentence, please. Yeah?
Yep.
Now, let's see.
That's right.
Not nice. It's beginning good for you?
Yeah, I think so. Yes.
Both Pulsar and Kafka are powerful, but
powerful, yes.
Yeah, Pulsar is on some layers better.
Yes.
And from a developer's point of view, I think Kafka is maybe a little bit better. So ChatGPT is not always right, right?
Yes, that's right.
No, just kidding. Almost right.
Yeah, that's right.
So let's continue our talk,
cool.
right?
Okay. Yep.
So.
Awesome. Okay. Very cool. So before we start, let me just first introduce myself. My name is Grygleski. I'm based in Chicago. I'm a developer advocate at DataStax, and the company that's actually very more popular for its Apache Cassandra platform. How many of you, just curious, are working with Apache Cassandra, let's say? Yeah. A few of you too, okay. So that's the company's kind of more famous for, but then 2 years ago we started doing event streaming and using Apache Pulsar, and that's why I'm here. I'm developer advocate for that. Prior to that, I was with IBM, and I've actually been to Devoxx Poland in the past two times, like 2019 and then last year, talking first about reactive systems and then about event streaming last year. So this year, bring back with me, or kind of joining with me as a co. So that's me. And then I was also a developer prior to becoming an advocate for over 20 years too. So that's kind of my background. I'm also the Chicago Java Users Group president, and also I'm also Java champion too. So that's a bit about me. So we have Ko to talk about. Ko.
Yeah, sure. Nice that you're all here. My name is Turk. I'm working for a consultancy company within the Netherlands, Bluefire T. And I really love my job. I'm really a developer, so I'm really into the code. I'm also using Kafka. And nowadays also a little bit Pulsar. Thank you for that, Mary.
That's right, yes.
And it's pretty interesting, both worlds. And we try to join best of both worlds, right?
Right.
So I love to speak. Thank you, Devoxx Poland. I love to write. And what more? I love Kafka. And I'm going to the Utrecht Juk. So if you are in the Netherlands, go to the Utrecht Juk. It's really nice. And follow us on Twitter, right? And that kind of things.
That's right. Yes, okay. Yes, so then this just about, before we start, if you'd like to have a copy of our slide deck, it's here on your right side, and then also we have some code demo that will be on the left side of the GitHub repo if you want to take a quick picture. If not, don't worry about it because we'll be sharing these information with you too, with the organizers. And then you can get to us anytime, like through Twitter or LinkedIn or any social media too, and we can share with you anything that you may be looking for. So.
Yeah, so Mary is more about the architecture, I see it mostly, and I'm more a developer, so we also share some code. So there's a lot of code to show later on at the end, and first some architecture, right?
That's right, yeah.
So what's in it for me? Choosing which streaming framework suits your case. Like I'm going to use Pulsar here, or maybe I need to use Kafka, and maybe I can use both. That's right. And we are going to create a basic Kafka and Pulsar app, and we are going to do also some more advanced stuff. And there is where they differ. So please stand by here. And how to stream like a pro, and not like YouTube, but real streaming with functions and streams.
Yeah, exactly. So we're all excited. So then this is our agenda for today. We'll welcome you to the streaming world, some introductions first, and then talking about streaming architecture. Then also, like, why should you consider both architectures, Pulsar and Kafka? And then also some demo, as Cole kind of brought up too. We also have a bit of an emphasis on Pulsar functions and also versus like Kafka streaming API. And then we'll try to bridge the two together. How can we bring both to work together instead of saying that one is better than the other? They each are built for specific purposes too. So, yeah.
So welcome into a streaming world. And the possibilities are endless. I think streaming is really nice, especially if you're working with big data. I am working at a big bank, and there you can assume they have a lot of data, a lot of billions of transactions or millions. And you need to process that on a Pulsar way or on a Kafka way. So you can see it like this. This is the Louvre in France, and that's maybe better. Yeah, no problem. And the big building behind is more like that is Apache Kafka. Like it's mature, it's already there, everybody is using it, and it's really nice. But you have also something really new, and that's something like the museum, like the pyramid, and that's something new art. It has some a difference with the major thing, but they also have their good part. So they have different use cases there, and we are going to talk about that.
Sure. Yes.
So Kafka or Pulsar, Mary?
That's right. So the question now is about whether we want Kafka over there, or do we want Pulsar, right? Yeah. So again, like they are not really that old, but it's a little bit older, I'd say, for Kafka because it came out in 2010, in that earlier 2010s time period, and it addresses a lot of the distributed messaging, which is really great, right? The broker and everything, and it's still going strong, and it's very widely used, got a huge community of these things. But then there's also Pulsar that came along as to why Pulsar, kind of came into the picture and as to why it is better too. So let's kind of like talk about which one, what do they address, right?
This is Franz Kafka, this is a novelist.
Right. That's right. So it's Kafka, the real Kafka, and then Pulsar, the star. So.
Yeah, but we're using it a lot, right? Can you tell us more about it?
So then you may be wondering too, right? Then who are the users of Apache Pulsar or Apache Kafka? As you can see on the left side, this is Pulsar is gaining in popularity, and then so is Kafka. Is like everywhere. Actually, I forgot to ask you, how many of you are already, let's say, right, are using Pulsar by any chance? Just wanting to know too. Anybody? Nobody?
Yeah, one. You need to do something, Mary.
Oh, sorry, we're getting older. I can't see. But anyway, okay, so that's good. I just want to get a sense of it. I know Pulsar is a bit like newer too, and not that new, but it's newer, definitely younger, let's put it that way, than Kafka. So, but again, these are, as you can see, these are like bigger companies, enterprises that are already using Pulsar, and then a lot more also using Kafka as well.
So LinkedIn already use it, and if you want to see the use cases, there are a lot of use cases. A lot of people are using both, so both are mature, and you can use it, right?
That's right.
There are also some books about Pulsar. You can already read it. They are good books. And also one is of your company, right?
That's right. So the one here on the third one, Apache Pulsar versus Apache Kafka, that one is actually written by Chris Bartholomew. He's the engineering director for our streaming unit of the company too. So yeah, he wrote about that. That was 2 years ago, I think. Yeah. Like something
so
like that.
yeah, it's still something nice to read if you want to deep dive into Pulsar.
That's right. Yes.
And yes, tell us more about Pulsar.
Yeah, let's then talk
stage.
a bit about Apache Pulsar. I know I came last year to talk about Apache Pulsar, but this time it's a bit higher level. Let me review it for some of you who's been to my talk before or already know about Pulsar. But for those of you who are new, if I want to kind of sum up, a little bit about the highlights of Apache Pulsar, I'd say, right, it's a high-speed, right, event streaming platform, and it's really built more for the cloud-native platform to more suitable, I suppose, like its strength is in the cloud-native type of environment. So again, very fast, it allows for high-speed ingestion of data into any system. So you basically, usually too, you'll be using Apache Pulsar, just like maybe with Kafka, you ingest the data using that, and then also then you can build pipelines and then pass it on the data to something like Apache Spark, Apache Flink, right, for more stream processing type of applications for real-time analytics. There are other Apache products as well. So high speed, and also too, I just want to mention about the highlights, right? Why is it different? Again, the fact is it was designed, basically Yahoo engineering started doing it in 2012, like after Kafka became in existence from LinkedIn. They decided that, well, there's a bit of limitations when you are operating Kafka in the cloud environment because it just doesn't scale as well, all of these different aspects. Maybe some of you who are familiar with Kafka. And so in the early days especially, so Yahoo decided we're going to do a better event streaming platform, better in the sense that it can operate better in the cloud-native environment. So some of the features, for example, is like geo-replication. You see all the planets there. It's basically wanting to say geo-replication. So basically, it helps with high availability redundancy of your data center. You can have multiple data centers in the world, right, or in the region, different regions. And then so you want to have that very easily, all the data to be replicated across like different data centers. And also it allows you to do message selection too. So it's not just like blindly replicating, but you can also do selective message replicating, all of those things. So just sum up, that would be one feature. Another feature will be like, basically it separates out the compute. Pulsar, right, separates out the compute and also the storage. As we know, event streaming platform deals with many messages, many meaning that, it can be up to petabytes of data or something, and lots of them. So you need to deal with all of the laundry baskets of all of these log messages. You want to store them. So instead of Pulsar worrying about it, because Pulsar is already busy enough managing all of the message delivery, managing all of the, message has all of the things too with what to do with message retry, all of these things. So Pulsar is taking care of the messaging compute part, and so it lets Apache Bookkeeper handles all of the storage part. So Bookkeeper is the one that handles it. So that way you separate out separation of concern, plus it helps with like independent scalability. And then also there's another feature too, is basically the multi-tenancy too. So natively, Pulsar supports that. So multi-tenancy is basically allow you to, let's say you have a cluster and you're housing multiple tenants, right? So it helps with organizing all of your messages. Otherwise, they all come in the same. So natively, Pulsar already has that feature to do multi-tenancy. And then another feature too, which is special, is basically with Pulsar, is that allows for tiered storage offset. So what it means is that all of your topics, your messages are stored, kept by Bookkeeper, but it can grow to a certain size, and also too, messages can become kind of inactive. So you don't want to consume all of the resources in your cloud, and it costs much, higher to. So you want to then move them to offline storage, right? Not so much offline storage, it's just cheaper, like offloading to some cheaper storages, such as S3 or Google Cloud Server, all of these things. So Pulsar has that also feature built in kind of natively to work very well too. So these are just kind of like a quick kind of introduction of Pulsar.
Yeah, I like the multi-tenancy thing. Like in Kafka, you have a lot of topics, and in Pulsar, you can really have a structure here. Like, hey, this is customer 1, and this is customer 2, and it's more I like that about Pulsar.
That's
I need to agree.
Yeah. Okay.
So yeah, about multi-tenancy, right?
Yeah, and then this is just a, I think we were preparing for this, and Cole was saying that, can you explain multi-tenancy better? So basically, this is just a picture to illustrate it, right? So it creates a nicer kind of, you have essentially one physical, kind of a set of all the messages, but logically, it divides up for you to allow you to manage all of your messages according to tenants, right? Tenancy, multi-tenancy. So, for example, like you have a cluster, you can have finance department is its own tenant, manage all of the messages there. You can also use different namespace to separate out all of your different messages, like for better organization. So, like this would be a picture to illustrate multi-tenancy. So, yeah.
Wow.
Thank you.
Nice. Thank you.
Yeah. Thank you.
I'm glad that you're here.
Yeah.
Glad that you
Thank
are
you.
here. So yeah, Pulsar, why? Oh, I need to say it why.
Yeah, you say why now.
Yeah, I think it's,
Yeah.
I hear it, like, I think it's really a good performance it has. And
right.
yeah, the scalability is something we like.
That's right.
Consolidation, the message replayability, the geo-replication, and the future readiness.
That's
Do you
right.
want to add something to that?
I think
Ryan?
it's good. Yeah,
Yeah?
yeah, that's right.
Yeah?
Yeah, cool.
Okay.
All right.
So,
Yeah. Oh, yes. So let's say can now talk about Apache Kafka. But first of all, we said let's share with you too some more resources. So there's a QR code if you want. Right, scan this to get more information first.
And this is the server part, and later on we will also cover you with the examples. Yes. So if you want to run Kafka on your own machine, that's also possible. That's right. So books.
Oh yeah, books. Yeah, that's mid-heard. Okay, so yeah, for Apache Kafka, these are just some of the highlighting some of the books that are more popular first, right? And there are tons of them too. So there's another QR code up there you can scan for more resources for Kafka books too. So. Yeah.
Nice.
So, yeah.
Tell me more about Kafka
Yeah,
now.
That's right. Yes, and now we want more about Kafka. Yeah, your turn.
Nice. So community is really mature, and the strength is really good. You have everywhere. You have examples, and nowadays you can also ask ChatGPT or that kind of tools. And it's really mature, and everybody can use it. And most bugs are solved, and it's really strong. A lot of tutorials, what is said, a lot of books you can check, and there are no bad days. I'm developer also. I'm developing with Kafka, and it's really nice. Really, the Kafka streams is something what is really nice. It makes it more functional and less complex and more easier to understand. It of course depends also on the developer. So Kafka, I like the simplicity. Like I'm from a developer perspective, it's really simple architecture. I will show you in some minutes. Mature performance is also really good. Replayability is also good. It's a little bit same like Pulsar there, I think. And fault tolerant. If something is failing, it feels hard, and you need to do something. And there you need to think about exception handling and maybe also some metrics, like the Spring Boot actuator is really handy here because you need to know if something happens that you need to do something. So, how does it work?
Yeah, how does it work? Okay, let's kind of get more into a bit of the high-level architecture. Yeah, so let's click.
Oh, sorry.
Click yeah, no problem. So this is just summarizing, right? If we kind of ask about what is Pulsar, first of all, right, what it is. And so this is just a diagram describing it. As you can see, right, there are essentially different parts to it, but the core of it is basically the broker. The broker is a serverless Java JVM runtime, right, serverless. And you can be, in a typical installation, you can have multiple brokers, too, that are running. And each one of them also holds, they owns all of the topics, right? And the topics, they are all partitioned, usually, because if you partition them, and it just increase chances of, kind of no failure, or even if there's failure, don't worry, because basically in a cloud infrastructure, you always will have backup kind of components running, right? Backup nodes. So anyway, so the brokers, and then brokers work very closely with the bookies, and bookies is the operating units of the bookkeeper. So each bookkeeper, basically, it always kind of have to run on 3 separate kind of physical machines too that handles all of the log messages, all of the messages logs, right, so to speak, and holds all of the topics as well. So it's very scalable storage too. It communicates, right, with the broker. So it's kind of really like kind of best buddy. The brokers will rely on on the bookkeeper to help with managing all of the log messages. You can do replays, so messages will never be lost, all of these things. And then there's also Zookeeper, just a note too, that it helps with like the metadata aspect, managing the cluster metadata. And just a little kind of preview is that there's, as you may have heard, right, if you're familiar with Kafka, we know that Zookeeper can be very kind of costs a lot of money, all these things running, using it. And so right now too with Pulsar, there's also a new feature called Oxir, is to help with more scalable metadata type of thing, but it's very new, but just thought I'd give you a kind of heads up for that. And then also too, then get back to Pulsar, then you write code, you write producer's code or consumer's client code, right? And these, you can write them not just in Java, you can do in many different languages, such as Go, Python, those are kind of really popular ones, and also even .NET, C#, C++, and all of these you can write too. And there are community contributors that help with, for example, like Scala, Haskell, all of these you can use as clients talking to Pulsar as well. Also a note to mention too, then even for Spring, with Java development, we are all mostly doing Spring. That's also got good support now for that. And also too, wanting to kind of mention also, there's also the Pulsar functions too, which we'll talk a bit more later. But Pulsar functions, essentially, they help you to transform your messages as you build your data pipeline, for example. And then also you can have Pulsar I/O connectors too. You can basically use it like data pipelines. You can build connectors, source connector, or sync connectors too. So a large variety of that. So that's kind of, it essentially sums up. Did I forget anything? There's also, I guess, the offloading to S3 buckets. All of these things are supported. Also too, it works with any kind of enterprise services like Elasticsearch or Cassandra as well. So it's basically very flexible.
Yeah, I like the connector thing, like of Pulsar. So you can eventually also, you have the Streams API, and you can also talk to Pulsar on the back end, right?
Yeah,
so that's nice, and you can talk through a Cassandra app or something, right?
That's right.
And other apps, so you can have one system that rule them all, right?
So, yeah, exactly. Yeah. So, yeah. Okay, so...
an overview of Kafka. You were talking about Zookeeper, and that's really energy-consuming things, but they also have something new there, so you can replace that thing. It's experimental still, I think, but you can replace that. What was the name? I don't know anymore, but you can replace this with another thing, so you don't need to use Zookeeper there anymore, so it saves you some memory, some energy, and that kind of things. How it works, like all the objects that you are sending from Java or from Kotlin or whatever, and you have a schema registry where you have your objects. So in a bank you have, for example, an account and you have a balance. So those objects, you can have it in a schema registry with a version 1, version 2, version 3. So if you change something, you can have on topic level, like, hey, this scheme or this object is living there on this topic with that key value. And you can produce it. I still have it's working, or no, it's not working. Yeah, there. So you have a producer and you have a consumer, so you can produce something and you can consume something, so that's very simple, right? And then you have something like brokers, that is having, if you have a message in, it will redirect you and knows which topic it has. And a topic can consist about different petitions. So you have petition 1, for example, if you want to have it all sequential, like just go like sequentially, but you can also have add a next petition, and then you have like more like asynchronously, so it's taking up on both petitions different messages. So it has an offset there, so it knows where you are and where you need to consume. So if you add a new petition, it knows like, hey. But the petitioning you are mostly set with topic creation. I really love Kafka streams, but there's a lot of possibilities there. You can use KSQL. So like SQL, you can have a query and look at your topic. Streams, what I said, you have Kafka Connect, like you can connecting one system, a database of an old one to a new one, to Elasticsearch or something, through a streaming way. So that's also possible, and Confluent is really nice into that, so there's also some tutorials in it, and I will redirect to that one. It's really if you want to learn more about Kafka. So, but why should you consider both architectures?
Architectures? Yeah, that's right. So as such, right, they each are good, in its own ways, right? So Kafka is, I think it just came out first. It's kind of very good like as a message broker, distributed messaging. But again, right, when you start to scale it, especially in today's world, like more cloud native type of environment, it may not be, as kind of efficient in that sense, right? So let's see. Okay, so just to give you an idea, right, if we compare, the two, Kafka and Pulsar. So if you look into it, right, Kafka itself doesn't separate out the log messages and the compute. It does both itself. So as such, over here, it's very partition-centric. As you know, if you're doing like even with your subscription, like consumer, right? You have subscription group, and it's very, again, more partition kind of centric kind of approach. Whereas if you kind of look over in the Pulsar side, right, it's more like basically you have different, brokers, and because of the bookkeeper handling all of the log messages, and bookkeeper handle it also in a very segmented kind of way, right? And so as you can see over there, it's got, even though you might say, you may argue, right, having another bookkeeper process will increase performance. True to a certain extent, but then if you're talking about message system that handles, trillions and, many messages, it's actually very good you have somebody else to help you. Otherwise, if, as Pulsar myself, I have to deal with the laundry basket of all of these messages, I don't want to deal with it. I want to worry about delivering my messages, taking care of all of these things. So these are kind of like what right then and there, we are comparing the two, Kafka and Pulsar, how they kind of manage all of their messaging and, all of these things behind the scenes. So, yep.
Cool. We're going to use
right.
Apache Pulsar functions, right?
Functions, yeah, that's right.
Yeah.
So when we talk about event streaming platform, right? Yeah. Why am I doing? Yeah, that's good. Yeah, let's do that too.
Okay.
But we're talking about, we'll be good to discuss about what kind of use cases we can think of, to use distributed messaging systems. You can think of many things, but one of the things I thought was fun, as you can see, this is something from Netherlands, from the country code came from. It's basically, we can be creative, but let's say, right, I have heard of, there are cows that you let them out in the field. And so sometimes the cows roam around, you can't track them. So how about put some IoT devices on them? And you can have millions of cows running on the field. And so how you locate them is that, from your IoT devices, it keeps sending all of your GPS location to a server somewhere. And then in the meantime, right, you kind of be overwhelmed with a lot of data coming in. So in other words, you can kind of think of using an event streaming platform, have IoT devices collect all the GPS location, so you won't have to worry about losing your cows, right? So that would be something you can use it for.
Next time we need to create an app or something for it.
Localize
your cow.
Exactly. So okay. And then there are also, then we talk about Pulsar functions. So essentially you collect the data. So very often too, you want to make sure, your data comes in, you need to do some sort of transformation, let's say, right? Whatever you need, filter it, all of these things. So basically in Pulsar too, you don't need to search for another way of doing it outside of Pulsar. Because within Pulsar, there's also a feature called Pulsar functions. So it's very nice. It kind of operates kind of like Amazon, the AWS Lambdas, or GPS, or what you call it, Google functions like that. So within the same ecosystem, you can use Pulsar functions to transform the data as the data travels through your pipeline. That's the idea. So you can use Pulsar functions, you write it, and they are very easy, very lightweight. So you essentially let the infrastructure manage, the infrastructural side of things for you. You just need to write the code, very lightweight again. For example, things like you want to filter some messages, you want to count the number of words, some usually kind of programs they like to do, right? And as the data flows through the pipeline. And then also like large enterprise systems, right? For example, you want to have it, kind of go through, spotting for like fraud detection, right? If you are a bank or investment company, you want to make sure that nobody is tampering with all of your data as they travel through the pipeline. You want to safeguard all of your investors' accounts too. So you can kind of think of using it for fraud detection, for example. You need the real-time kind of capability to it too. And so yeah, and then again with IoT applications like the identifying lost cows, things like that. And then also wanted to kind of mention too, at DataStax too, we actually have also this function called transform functions. It's basically a low-code alternative. Basically, these are pre-configured functions you can use sort of out of the box as well. So these are Pulsar functions. You write once, you deploy it, let the infrastructure manage it for you in the cloud. So yeah.
We show it also later on in some minutes, how it works, right? And from a developer perspective, so pipelines.
Yeah, pipelines. Okay, oh yeah, I also
going good.
Yeah, so again, we talk about data pipeline, just wanted to kind of make sure we are all on the same page. So essentially, if you kind of look at data, it's kind of like water flowing through, your whole pipeline, let's say, right? So that's why we use this kind of imagery of water kind of coming out of a faucet is your source. It flows through some pipeline, and then it gets through somewhere to purify or do whatever you need. So that will be more like a Pulsar functions in there to transform all of your data, make it clean, and then when it's ready, you deposit all of your water to a sink. So that's the idea of the data pipeline. And as such, you can hook it up different data pipelines together to make it a giant flow as well. So that's the idea. So yeah, that's data pipeline. And so now, again, kind of mentioning about Pulsar functions we summarize on this slide deck is that it allows you for complex stream processing in a very lightweight type of manner. And it's kind of inspired by AWS Lambda, the Google function, like that. And currently in Pulsar, though, it's only Java, Python, and Go supported at this time. And there are also efforts to increase support for other languages, too. So that's the idea.
So we are saving a lot of memory there, I guess, right?
Yeah, that's right. Yeah, yeah, that's right. Talking
Sustainable.
about sustainability. Yeah, Cole has a talk about sustainability.
Oh, thank you.
Yeah, that's right. Yeah.
So yeah, go on, and then later on I will show the demo.
Yeah, we'll talk to. So just a really kind of a quick kind of summary. These are the different connectors that are pre-configured in Pulsar too. So as you can see, there are databases, messaging systems that includes Kafka in here, all of these major vendor kind of libraries and products, and then different language clients listed over there, and also monitoring capability like Splunk or Datadog is supported. Other kind of like software as a service, SaaS platform like Twitter messaging or SAP HANA, all of these are supported as well. And then if you actually don't, if you don't find what you need in there, you can also write your own connectors too. And there's also a Pulsar I/O connector SDK that you can use to write your own connectors as well.
So we're going to the demo, right? We will show you how it works and how you can use a platform like DataStax, of course. And we are going to talk about
that's right.
Functions,
and just,
right?
Functions.
Maybe you can tell about it.
Oh, this one, that's right. Yeah, just again, I brought up too, you can use Spring quite easily. Now they're starting to have support for Spring, for Pulsar client for Spring. I actually recently did a talk at Spring I/O too. So there are resources in here as well that you can look up. So
yeah. So now going to the demo. How much of you are developers here? Can I have a raise of hands?
Yeah,
and who are not?
Yeah, yeah.
Okay, almost everyone is nice.
Yeah.
So I can give a demo and then know,
right,
like, hey.
yes.
So I will share, I will mirror first, and then going to the Pulsar. So we have a project. It's also on the GitHub slides, and and GitHub will be shared also later. So the full example you have. So the basic one. What do we need, Mary? Like, what do we need to have in the POM?
That's right. You do need your Spring Boot and the Spring Framework starter.
So there's a Pulsar Spring Boot starter you can use already, and it's still experimental, right? Or it's almost there.
It's there. Yeah.
It's the 0.1 is there already.
Yeah, it's there. Yes.
Nice. So you can already use it, and it's pretty easy. We want to use functions like it's a low memory, so you need to think about lambdas and that kind of things in that way. So, I'm having the basic by the one. I needed to talk about the function, and the only thing you need is to have the Pulsar Functions API. Sorry, I was mixing things together. Sorry, I was talking about functions first. And the only thing you need to know is the Pulsar Functions API, and you only need to implement a function. So this is the only thing you need to write. Of course, you have your own logic, and you need to implement function, and then you can think of very tiny
that's right.
lambda functions, right?
That's
like,
right.
Yeah.
Yes.
So you can upload this, or you can use the CLI,
You
right?
can command line as well. Yeah.
Yeah, so that's possible. So that's pretty easy, right? And then if I'm going to DataStax, I can check, for example, I can log in with my GitHub, and then, yeah, it's pretty nice. $25 are free, and you don't need credit card and that kind of thing. So if you want to try it. It's free, and it's really easy. So what Mary already talked about is like the multi-tenancy. So we have now a world, but you can also think of different customers there. So you have a customer 1 and a customer 2 or a customer 3. So you have multi-tenancy there, right?
That's
yeah?
right.
Yeah, okay.
Yes, these are all supported. So. Yeah.
So yeah, you can use different applications.
That's right, languages and applications. And just wanted to point out, right, this is the managed cloud platform of DataStax. So it's astra.datastax.com is on the slide deck too. So we like to invite you to try it out, and it doesn't cost you anything for the first $25 for the free tier. So that's what the code is.
It's nice for POCs or something. You want to check something, and it's really cool. I also connected my own Kafka applications to DataStax or Pulsar, so that's pretty cool.
Yeah.
So what you have is like the functions, and within functions I created my own functions and payment, and it has some variables there. You need to say it's a jar. Now I'm just uploaded it manually, but you can also use the CLI if you want. And then you see some loggings, and then it's running on the cloud, like it's running, it's sending something. So it has a system out print line, so it doesn't consume a lot, and you don't need your loggers and that kind of thing. So it's pretty back to basic, easy, and that's a kind of art almost, right?
Yes, exactly. Yes.
So that's more about functions, I think. And you have namespaces. Do you want to tell something about the namespaces? Or
Yeah, that's right. Yes, so exactly. So within each tenant, right, you are defining your tenant. You always have some namespace that you can assign to that too. Of course, there's also a bit of a limitations, but for what you need, especially if you start off using a POC type of thing, and there's like plenty, that you should be able to kind of use the limit that they give you right now. So so namespaces essentially kind of helps you to segregate, right? To isolate your different, in your multi-tenants kind of system. Within each tenant, you have all of the namespaces further kind of demarcate their boundary too.
So we have structure there, right?
Structure.
That's pretty nice. So we have, you see like a namespace about Kafka and one of Pulsar, and it has different topics. So you also have structure there, like, hey, I have a Kafka namespace, and it has these topics, a balance, a blacklist, fraud, payments, and that kind of things. And that's pretty cool, because I can work with my own applications, which I already use, like Kafka Streams. I can still use it against Pulsar, and that's the connector thing, and it's really powerful, I think.
Exactly.
And we want to talk about maybe the basic stuff. You can also, what I said, this is Spring Boot integration. We already talked about it, but you can use something like GDC template. You also have something like Kafka template, and you now also have something like
Pulsar template, and also just a note too, if you're into reactive. We also have reactive Pulsar template as well. So there are two kinds, But for here, I think we're demonstrating only the Pulsar template, right?
So the Pulsar templates is really nice. Like GDC template is kind of also structured. So it's a word of the day, structure.
Yeah, that's right, structure. Yes.
So you can just send it, just .send with the payment, or if you want an object here, you can say like, hey, new balance or new account with a key value, and you can say you can talk Avro if you want, right?
Yes,
or you can talk JSON or whatever, or string.
Or protobuf as well. So,
protobuf. Oh, wow.
Well.
Okay.
So, yes.
Back to a basic. Nice.
That's right. Yeah.
And also the consumer, like you have a Pulsar listener, like you have a Kafka listener. I don't know if you have a JDBC listener, but I know that the Kafka listener there is. And it has a subscription name and some topics. And that's the only thing to receive some message. You just say get message, and you can set it, do something with it within a database. So.
That's right.
Wow,
yes,
it was easy, right?
Yeah, it's not that complicated. So
So that's more about Pulsar. Are we going to Kafka? We are doing later on, right?
Sure. Yes.
So back to here.
Okay. Actually, maybe one note before I forget to, I was thinking multi-tenancy, right? In a kind of use case too, this thought I'd share, is that the use case, for example, if you're a data center and you're running your clusters, you have many companies, right? That you're running their data on your center, and they're same physical cluster, but you want to separate them out. So that's where multi-tenancy can come in. You can have tenant that's one company A, company B, all of these things. So that would be a use case that I suddenly thought of too. Thought I would tell folks still. Yeah.
Next time we do pair programming or something.
That's right. Yeah.
So Apache Kafka, still needs switch, and Apache Kafka, yeah, it's already mature what I said, and I love it. I also have a Kafka folder, so you can look. So there are two things already. So if you want to use the basic stuff like Kafka listener you have, and also Kafka template, you can also use it on a Kafka way. And the same thing you can do here, like there's a starter somewhere, and you can use Spring Kafka, for example. And that's really powerful, more or less works the same, so I don't want to put a lot of attention in it. It's already there on the GitHub if you want to check it. But what the cool part is the topology, the advanced stuff, so the streaming part. So we're talking about streams here, so we want to send a lot of data through our pipeline or to our topics or that kind of things in a streaming way. It needs to be very fast on our petitions, and yeah. So yeah, you have different streams here. So you have a payment stream. So we want to handle payments, and we want to handle frauds. So what is really cool, what I liked, if you don't know a lot about Kafka, there's a really interesting website you can use. And if you also print your topology description, you can also visualize it, what you're doing. And that's pretty cool of it. Like here you can see, hey, what am I doing here? Is it?
Nice.
Yeah, it's CML, right?
So
you have a payment, and a payment, I want to do something with it. I want to peak, for example. That's just print, creating metrics. It's very important in streaming environment. Use actuators. So if you have 100,000 exceptions, you need to know, hey, maybe I need to do something. You can join. So we are going to join the balance with the payment. And then you can see like, hey, there's something happening here. It's a sort of state store here. So it's handling state there. And you can join those two together, so the balance and the payment, and check if you have enough balance on your account. Yeah. So it's pretty cool. And yeah, you can filter on it and that kind of things. And we send it to the fraud. And you can also know doing a branch split. First, I want to show it. Like the payment stream, it's like more or less showing like this. Like we're creating a K stream with payments, and we have a table with balance. So this is a payment with balance information and needs to update it very quickly. So we want to peak it, so we're checking the balance. And maybe you can create some metric. Hey, this is payment X with message type this. So you can also follow which kind of payment it is or something. You can join both, what I said, like join the balances with each other. And you can filter on it, like, hey, I need to have enough balance, and then I can go through. And then I will map it to a next object, like a fraud, and send it to another topic, which send it to check the frauds. Maybe it's a fraud and that kind of things. So in a big bank, that's very important that you check those things. And yeah, one more thing about this one is that you also have exception handling. So for example, if you're getting a message that you cannot get, or you cannot merge, or there's something with it, you cannot deserialize, then you can have all kind of exception handler here. Like a deserialization handler, like, hey, just continue if you have such a message, because there are also other messages on that topic, so that's possible. Yeah, you have an uncaught exception handler, so you can check all kind of things, like maybe you have a red pill, a blue pill thing, and you want to do something very important, and because otherwise your application will be down. So more that later on, or after the talk. What is also really cool is the testing. You can also use testing with the topology test drive, or you can use test containers just in memory, and that's very fast if you want to test it. So you don't need to have a whole cluster. So
that's right.
Sorry,
No,
back to you.
good. Yeah, no, it's all good, yeah.
So, back to the other one.
Slide, yeah.
So bridging the two together.
Bridges too, yeah. So okay, so it's more like you're thinking, after we talk about each, right? So you're thinking, well, can we actually make the two work together? Of course. And so this is what we kind of want to quickly introduce to you too. If you want to integrate the two together, there are many ways too. But this is like one of the ways. That's from DataStax. We have this. Do you mind advancing the slides?
Yeah. Oh, sorry.
Okay. Yeah. So at DataStax too, we have also a open source kind of free tier API layer that you can use, which is called Starlight. And it's not only actually with Kafka, but because this talk is more about Kafka and with Pulsar, so we invite you to look into that. You can try the Starlight API. It's basically protocol level, kind of making Pulsar talk to the Kafka too. So let's say you already have Kafka installation in your environment, or even here too, JMS, or for some older applications, and they are running fine. Why do you want to rip them apart, right? And also even RabbitMQ. You can actually have them coexist and basically use these Starlight API to talk to your existing kind of older infrastructure too, and that will work. So just wanting to kind of point that out to you, that you can basically use these options to integrate Pulsar with Kafka as well.
Yeah, that's the connect thingy. So I can just connect my own application, which I'm using Kafka. I can redirect to Pulsar if you want. So yeah.
That's right. So
wrapping up.
Good. Yeah.
Pulsar.
So wrapping up. Yeah, we're just 4 minutes. So just wanting to kind of summarize again, right? So Pulsar is basically more it's a bit newer, right? New, maybe not as kind of broad kind of usage yet, but I think it's up and rising because of its capability to operate really well in the cloud native environment. Has all of these native kind of features like multi-tenancy, geo-replication, tiered message offloads, all of these things. And basically, too, Pulsar components are very scalable, horizontally scalable, and also with the tiered offset, tiered storage offset too is very kind of applicable in a cloud environment. And again, it's also kind of like Kafka too is open source, and the community is growing too, and there's also no vendor lock-in. So how about Kafka?
Yeah, I'm still loving Kafka because I can still use it, my own application. So that's the best of both worlds, right?
That's right.
So I can still use my own application, my Streams application. That's really nice. A large community, also the same. I already said it. More support and examples to find about Kafka, and a lot of flavors. So you can use Kafka Connect or KSQLDB, and that's also something like Drive Kafka also.
That's right. Exactly.
So the key takeaway.
Key takeaways. Okay, yes. So we wanted to say, okay, Apache, Pulsar, right? Functions basically are there. They're great, kind of memory saving, kind of help you to write, a lot of your functionality as you build your data pipeline. So it's in a way, it's like a serverless computing kind of framework, very efficient, very, fast, also real time, and all of these good things. And write once, deploy, and let Pulsar manage it for you. And then there's also, Kafka Stream as well, right? If we
I love the Pulsar, the backend, the server. Kafka Streams is really nice because you can make it very less complex. Like you can just make it in a functional way and make logic easy, I think. And I think it's more developer joy. And you can still use the benefits of Pulsar. So we are joining here.
Yeah, that's right. Yes.
Nice.
Exactly. So. Awesome.
Resources.
So this is just some resources to share with you. These are not limited to these, but just wanted to bring to your attention the Apache Software Foundation, all of the information on Pulsar, Bookkeeper, and also Zookeeper. And then also at DataStax, we have our astra.datastax.com. That's where you can sign up for the free $25 every month. You get renew for another $25 next month too. That the managed cloud platform that Ko was showing you. And then there's also the Astra Streaming, which is our managed cloud platform. There's also Luna Streaming, is another distribution where you can deploy to your own cloud, and we can help with support as well if you like. And then there's also the Starlight for Kafka link, and also there's another feature called Change Data Capture if you are into that too. That's also supported on our Astra platform too. So,
nice.
Yep.
Right on time. We also have some resources about Kafka. You can run your own Kafka server, and also on my GitHub you can find some Docker containers if you want to run it. Zookeeper can be handy, but what I said, you don't need to use Zookeeper anymore. They have something new you can use there. And more info about Kafka, you can also watch that that link or that QR code. And
Okay.
yeah.
And now
Yeah, please vote, I would say.
Yes.
Help us to improve us, give feedback. And if you vote 1 star, please give us feedback why.
Yeah.
And if you are thinking it's really great, we are happy.
Yeah.
So, we want your feedback, so that will be very helpful.
That's right.
Your famous last
so
words.
Thank you. Thank you very much. Thank you so much again for coming to our talk. And yeah, thanks.
Thank you.
Thank you. Yeah.